here we have a wall section of an aquarium, and that is made out of concrete and other insulating materials. And we know the average thermal conductivity for those materials that is known to us. And within that section, we have a clear plastic for viewing, and that is 6-inch thick with a thermal conductivity of 0.195 here. And we also know that the inside temperature of the room is kept at 70 Fahrenheit, and the heat transfer coefficient for convection is also given to us. And for the water tank, the temperature is also known to us. So on the other side of the concrete wall, it is exposed to the water tank, which has a temperature of 50 Fahrenheit, and the heat transfer coefficient is also known to us. So we have to use ANSYS to plot the temperature distribution across this wall section. Okay, so this is our problem. Now let us move to our ANSYS Workbench. I have here. So for this particular problem, we will be using a steady state thermal analysis. So just double click that and you will have a new project window start appear here. Now, first of all, let us define the materials. So we have concrete, and for that we know the thermal conductivity value that is given to us, and make sure the units are correct. So we have BTU per foot square R, and the value is 0.81, that is here. And then we have the plastic sheet, so plastic for viewing purpose, and the thermal conductivity value, isotropic thermal conductivity value for that is also given to us. It is 0.195, so 0.195. Okay, so first of all, we have to define the materials. Once that is done, let's go ahead and close this thing. Next, moving to the geometry. So double click the geometry and the space claim window will appear. Okay, so now we have this space claim for the geometry. So first of all, we have to check the units. Okay, so let's go to File and then space claim option, and here I'm going to units. Since in the image that is provided to us, it's all the parameters are in feet, so let's convert this thing to imperial and feet. Click OK. Okay, now we have to draw. Since we have two material type that we are looking for, so what we can do is let us create a new component. Okay, and let's name it concrete, and now let us draw. So okay, so I have a block of 7 feet by 2.5, so 7 by 2.5, and then go to the 3D mode. Then it has a thickness of 18 inches. So what I can do, I can pull this thing upward of 18 inches. That will be 1.5 feet. Okay, so this is the structure we have. Now we also know that there is a viewing window, so we have to create that space. Okay, now let's select this plane. So, okay. Now for the window, that is 0.5 feet from the top side and 0.5 from here. So let me draw a construction line just to identify the point. So it is 0.5 horizontally, and then 0.5 here. Okay, so I just created that to get my first point for the rectangle. So here it is, and the rectangle is 3 feet by 1.5, so 3 by 1.5. I have this thing. Okay, now I can go to 3D and then just again use the pull command and just move in the backward direction to remove this material. Okay, so this is the concrete block we have. Now next is we have to create a a second object for our plastic viewing window. So let's go to design and create a new component, and let's name it plastic. Okay, and again we will be looking at this particular plane, so let's view plane. Okay, that is done. Again, going to the 3D mode, and the thickness of this uh, plastic sheet is 6 inches. So again, using the pull command, select that and move that to 0.5 fits. So that will be 6 inches. Okay, so now we have the two things. To just differentiate, you can do a bunch of different things. You can go to the display and change the color. So let's say this is dark blue, or select this and change the color to light blue. And we have two different things. Okay, so once this is done, we can save this thing and close our space claim. So let's save this. And close this thing. Now here you can see that the geometry is being attached, so that we have a green tick here. Now we can go to model, double click the model, and we have a new window will appear. Okay, so now I have this model open, but the project is still not there, so it will take a few seconds. Okay, now we have our geometry that is being attached. Okay, so the first thing again here is make sure that the units are correct. So we can go to the home page and check for the units, and we have the units here that these are correct. So imperial is selected with fit, so that is fine. Now going to the geometry, we have two solid objects. We have the concrete, and what we have to do, we have to assign the materials. So currently by default structural steel is selected, so go ahead and change that thing to concrete. And similarly for plastic, go ahead and change this thing to plastic that we previously defined. Okay, now for the mesh, you guys can pick element size. I will just go ahead and use the default setting. So let me go ahead and create a mesh. Okay, so this is the mesh we are getting. So currently we are getting the wire from. You can also convert this thing back to the shaded structure. So I have this mesh. Now let's go ahead and define the conditions. We know that the outer surface here for the wall and the plastic, the room temperature was 70, and we also know the heat transfer coefficient for that. So let's select both of these spaces. Okay, and go ahead to the environment and hit convection. Now the coefficient is given in the question, that is 1.46, but the units are in R, so we have to convert that thing into seconds. So equals to 1.46 divided by 3600, and the value of temperature is 70 Fahrenheit. Okay, that's done. Now let's move to the other side, and we have to define the temperature here as well as the coefficient that is given to us. So again, let's go ahead and select all the faces. I have 1, 2, 3, 4, 5, and one more. Okay, now hit the convection, and that is the second convection. So the film coefficient is equals to 10.5 divided by 3600, and the temperature is 50 Fahrenheit. Okay, so that's all our initial conditions. Now we can go ahead and solve this thing. So once you hit the solution, we have the thermal here. We are looking for the temperatures. So here's the temperature, and hit the solve button. Okay, now I had paused the video. It was taking a lot of time. So now we have this solution here. You can see the temperature profile here. So the maximum we are getting 65.66, minimum is 50. I can figure out where the maximum temperature is and the minimum temperature here as well. So that is here. Now what we can do is, again, just to check if our mesh that we just took, the standard one, is good enough or not. So let's right click the temperature and insert a convergence plot here. So let's go ahead and do that. And let's do the allowable change to 1% and hit solve one more time. Okay, so this step is really important because that will define either your results are correct or not. The plot has to converge here. Now almost done. Okay, so let's see here. It has just done one iteration, and here you can see that the percent change for just one iteration is like 4.6 10 raised to the power negative 3. So we are good. By increasing the number of elements, the temperature profile is still the same. There is no significant change here. So the mesh that was originally generated by the software was good enough for this particular example. Okay, we can go back and look. Now it has updated the mesh, and after by increasing the elements, we are getting the same results here. Okay, so other than that, we can also get the heat flux. So let's go ahead and click solution. I have total heat flux, and go ahead and solve this thing. So I'm getting the value for heat flux here as well. And what you can do, just to show how the flux is going across, we can do a vector display. And let's do uniform grid align, and let's do solid so we can see that. Okay, and I'm converting from shaded exterior to wireframe just to look at the arrows here. So let's see. Okay, I also don't want the elements, so no wireframe here. Okay, just increase the size. Okay, so you guys can play around with these settings to get some nice visuals to add in your report. So here you can see that now. Let's do a little bit zoom. How the flux is going across, and given by the arrows where the maximum value is, where the minimum value is, so on and so forth. And you can also run a simulation. Let's do that, and it will show you how the heat flux is going across your system here. Okay, so that's all for this example problem.